So, hello and welcome, everyone. I would like to thank you for joining today's webcast, which is on the topic integrating pure variants with multi-vendor toolchains. This episode focuses on how pure variants can seamlessly integrate into your system engineering processes, enhancing your software product line development. So, my name is Shivani Hegde, working as a solutions engineer at PTC, and I will be your moderator for today's webcast. I'd like to introduce Dr. Yang Li, who is a principal solutions engineer at PTC, who will be our presenter for the day. He shares his knowledge about product line engineering in the fields of solutions engineering and consulting, helps in pure variants tutorials, trainings, workshops to help customers on the journey towards systematic variant management approach. So you can register for them for all the upcoming webcasts on our website. You can also watch the recordings of the past webcasts. So now during the webcast, if you have any questions, you can use the chat system that you see on your screens and feel free to post them there. And only our webcast team can see your questions. So we will collect all your questions and answer them at the end during the Q&A session. And in case there are any open questions left after the webcast, we will follow up. We will contact you in order to follow up. So having said this, now I would like to hand it over to Yang.
Yeah, thank you, Shivani, and welcome everyone from my side. Today, I would like to share with you a general picture of integrating pure variants with multiple vendor toolchains to keep the consistency of the variability information across multiple engineering disciplines. Let's get started. To motivate the topic today and give you some background, pure variants is a tool that can be used to implement product engineering. Let me firstly see some words of what product engineering is and what kinds of problems can be resolved by product engineering with pure variants. I will go for cars as an example. So for example, when consumers want to buy a new cars, usually they have many options to decide what kind of cars they want to have. For example, the colors, or maybe the designs and functions for the car light, or driving assistance functions, which of course leads to the differences in the software system, right? Moreover, if they take the budget into account, there could be more differences and combinations of features and functions. If you have a look at this one from the car maker's perspective, all of these options will increase the complex variability in the product family when producing them. But you have to satisfy the needs from your customers if you want to win more market share. And this is what you have to do. And what could introduce more variability there? For example, your products will be sold in different areas and they should follow different regulations and standards across regions, such as different emission standards, right? And nowadays, more and more innovations and functions now come from the software, which means more complex variability are from the software side. And then customers want to keep the products they bought always fresh and have bugs fixed in a short time, which requires car makers having a good way to manage all the product variants to know exactly what and where to update. Last but not least, the upselling of new features and services also introduce new and more variability. Okay, so if we have a look at the V model for these cars, do you want to develop them as individual products? If you do so, how can you track the variability? Probably the traceability of the variability information is lost, which leads to the fact, for example, you cannot easily figure out which your products are affected by a software update or a technical issue. This increases your maintenance effort. And when you want to reuse some existing engineering assets, if you to develop something new, for example, if you directly make a copy of them and modify your requirements, models, source code, and so on one by one, which takes lots of effort and cost to do so. And it is not easy to keep the consistency of your variability information, right? Probably you introduce errors somewhere by accident, which causes very bad impacts if you want to have a safe or efficient development. Okay, so, but if we use product engineering with pure variance, you will regard the similar products as a whole rather than individuals in your development process. And pure variance will be in the central place, right, to control all the variability information and manage your variance to keep the traceability of your variability, guarantee the consistency of them, also reduce maintenance effort and enable fast reuse. Besides variant management in this V model, pure variance can also be integrated into your configuration management, change management, continuous engineering like CI/CD pipelines, or even your review process if you want to analyze your variance and so on, to have a holistic product engineering approach. This way, you use pure variance to make a configuration and then derive the engineering assets you need for a product variant. I'm using a car example here, but it can be also applied in many other industries like defense, aerospace, semiconductor, medical devices, and so on, where the focus is actually on engineering physical products that are very complex and software intensive. Or if you have this variant together with your configuration management and change management, so everything can be tracked, variability and version, this kind of stuff. Okay, then let's go ahead. So as I mentioned before, product engineering crosses your multiple engineering disciplines like requirements engineering, MBSE, simulation, code, and so on. If you want to implement a holistic product engineering, it's actually all about connecting all these areas in your development life cycle. Pure variance comes with more than 20 connectors to the most widely used tools in requirements engineering and also this other areas, MBSE, simulation, code, also change management, configuration management, a lot of them, right, shown on this picture. That is to say, pure variance as a product engineering tool can be well integrated with your overall toolchains. Okay, so after a general overview regarding product engineering and with pure variance, but maybe you want to know how exactly it can work, right? Let's have a look at this one. So product engineering with pure variance and also pure variance fully follows the standard ISO 26580, right? And with this approach or with this standard, there are basically two major engineering phases. The first one is the so-called domain engineering. In domain engineering, you engineer your program to make it ready for the systematic reuse for all of your product variants. Firstly, you have to create your so-called feature models, and where the features, the configurable features should be modeled here, and also the dependencies between the features also should be modeled in this feature model. For example, let's say whether one feature requires another feature, or whether two features are conflicting with each other. This kind of dependency information. So on the right-hand side, there's an example. This is actually a screenshot taken from the variance client, and this is a feature model for my car light product line. And the feature model is actually tree-like structured. You see some features here, for example, for the beam configuration, for low beam, high beam, and different types of these beams, right? Like xenon and halogen, also fog lights. This kind of features can be configured to for my different product variants. And besides the features, I also have some dependencies, like whether these two features are conflicting with each other, or whether one feature requires another one. And also you can see some attributes information, the parameters can also be stored in your feature model. Okay, this is the feature model, meaning that you have the central place holding all this variability information. And then besides the feature model, we also need to set up or build up this the so-called domain assets. So what is your domain asset? Yeah, let's have a look at this example as well on the right-hand side. So I'm using the requirements as an example. For example, this is my requirements in Codebeamer, and this is actually my domain assets, also the so-called 150% assets, or your superset of your requirements. Because you can see in this side of my requirements, I have all my common requirements and non-common requirements for all of my product variants in the scope of this product line. Yeah. For the common requirements, of course, all of them will be loaded into all of my product variants will be used there. But for this non-common requirements, we will just use the features we earlier created in the feature model, to say if the features, for example, USA or Canada is selected in my configuration, and then the corresponding requirements will be included into my product variant. Okay, this is the domain assets. So after that, after the preparation stage, so I have everything that I can reuse, right? Domain assets and feature models, right? And then later on, I want to really develop something new, a new actual product. Then we switch to the next phase, the so-called application engineering. And in this phase, I need to firstly create a so-called variant model. And what is variant model? It's actually where you can hold your configurations, right? You see you have also the feature model here. It's a feature model like the functional features and some sales regions here, and you have all the features here. You earlier model in the feature model, but the difference is like you have this checkboxes in front of the features. You just need to make a selection, make a decision here which feature you want to use for which variants. Then that's it. It's quite intuitive. Just to make a decision of these features, and that's it. And pure variants can also help you to check whether your configurations or maybe the selections are valid or not, because it knows all these dependencies in your feature model. Okay, then let's go ahead. Now you see we have the configuration, the feature selections in the variant models, and also I have the mapping information, the variability information captured here, and also all of my common, non-common requirements are here. Then, based on two pieces of this information, I can directly tailor the supersite to generate the variant-specific assets for a variant. I'm showing another example. This is the variant assets for a variant. You can see this is just a subset of my requirements from Codebeamer. I didn't include all the requirements here because I didn't have all the features selected, right? I just select some of the features, and then to just have a subset of these requirements only for this variant. You see there is no requirements for the fog light because I didn't have the fog light selected in my configuration. So what I'm showing you is the example by using requirements, but actually, if you want to use the same way or same logic in any other different engineering disciplines, for example, architecture, test case, and source code, you can do it in the quite similar way. That's no problem. Okay, then after this one, I want to introduce you to another dimension, another two terminology. So the first one is problem space, where you need to figure out, for example, some problems, what should be your scope of your product line. Then you can start to modeling your feature models and then also your configurations, because you know what kind of product variants you want to produce in this product line. So all the activities happening here in this problem space, you will just use pure variants to do that. For example, feature modeling, configure variants, right? And then later on, after you have feature models and variant models, right, and then you want to really implement your product, of course, you need to have the solution assets. Then we go to the solution space, and then you need to build up your domain assets, for example, for the requirements or for your source code, for your architecture models. And of course, later on, together with pure variants, you can directly tailor your domain assets but directly put them into your multiple vendor toolchains. For example, the Codebeamer requirements will be still maintained in Codebeamer, even though this is the tailored one, but it still will be maintained in Codebeamer, right? This is how it works now. So pure variance can work with together with this multiple vendor toolchains in this way. Okay, this is the general overview regarding the program engineering with pure variance, how it works. Then let's go ahead, because I want to show you a running example. You know the general picture, you know how it works generally, but maybe you want to have a clear picture how it can really work, yeah? So how you can do the connecting part, right? Then let's go ahead. So because time is really limited for this webinar, I won't really go for all the connectors we have, but I just pick up 3 of them, like this IBM DOS and Dassault System CATIA Magic Draw and Codebeamer. I will use 3 of them as an example, but focus on different engineering disciplines. For example, the requirements modules will be maintained in the IBM DOS Next, and then I have some architecture models will be in the Magic Draw, and for my test cases, I will use Codebeamer to handle them. Okay, this is the general introduction of this running example. Then let's get started. Firstly, let's look at the feature modeling part and how you can configure your variance, right, by using pure variance. Let's go ahead. What I'm showing you, this one is the pure variance desktop client. You see this our desktop client, and on the left-hand side, in this view, you see some projects. But in this running, just go for Carlight Proglan as an example, right? And in the middle, so I have 2 feature models opened. The first one is the functional features feature model, and second one is the sales regions feature model. By using pure variance, you can have multiple feature models for different purpose or different levels of your product line, right? And in this feature model, you see the different features for this for my Carlight. Like I introduced earlier, this xenon halogen, they are conflicting with each other because they are alternatives. And also have some optional features like this fog light or daytime running light. You can decide whether you want to include them or not. Yeah. And also I have some other features like this automatic light or countering lights below, under this driver assistance. So one of them must be active. We have another OR relation here. Yeah. This relation is actually based on the parent and child relationship. But if you want to do something like a relation or a constraint across the tree structure, you can also do that by using the pure variance requires relation. For example, this one, I have another feature, Sweden requires another feature, automatic hazard warning in another feature model. You can see this dependency is crossing the feature models. And then on the right-hand side, this is the variant model holding my configurations, right? You see in this variant model baseline for Sweden, actually I include 2 feature models, the functional features and also the sales regions features. You can decide, when you want to create a variant model, you can decide based on which feature models you want to do the configuration. So in this example, I just want to configure my variant models based on these 2 feature models, both of them. And I have some features like the feature automatic hazard warning, right? Use this feature later on, in my presentation. Okay, then besides the desktop client, so pure variance also comes with a web client. So meaning that if you have the web client installed in the central place, then you can easily involve more stakeholders into the product line related activity easily, right? And you can see now what I'm showing you is just a browser, where I have the pure variance web client opened. On the left-hand side, you see the projects, right? Like what you have seen in the desktop client. I would just open this automotive demo car lights. and you see some files like the feature models, configurations. Now I just want to open this feature model. You see basically the same features, right? Low beam, high beam, daytime running light, and this light, and also driver assistance. Because actually in my web client and the desktop client, I'm just accessing the same data. Yeah. And now I'm showing you this configuration space. Just open a variant model also for this baseline Sweden. You also see the same configuration here, like for beam configuration, and also daytime running light, the feature light is selected, and the value for the pulse is 100 by default. And also I have this automatic hazard warning selected. Of course, the regions, the feature Sweden is selected. Okay, so this is a general view regarding the pure desktop client and web client. Yeah, I have the feature models over there. I have the variant models over there. Then let's go ahead. Yeah, to see the next one. So in the next type, I want to use the features, right, I earlier created here in my feature model to control the points identified in my requirements. Yeah, I mean, stored in the IBM DOS Next. Let's see how we can do that. So let's go to there. You see this one is the IBM DOS Next. Yeah. So on the left-hand side, you see this is the pure variance widget for DOS Next. And in this widget, you see the feature models, right? Because I have the configuration open here. In this configuration, I have these two feature models configured. And if I want to know more, for example, you can see the project information and the branch information, whether this project is referencing another one, something like that. I can also expand the feature tray, and then you see some other features, like the Sweden feature. And then on the right-hand side, these are the requirements. Actually, this is my domain access, right? I have all the common requirements and non-common requirements for all of my product variants. Yeah, and then there's another column named PV restriction. Yeah, in this column, you see I have some features here, like this USA or Canada, that can be used to control the existence of the corresponding requirements. Yeah. I have many requirements here with restrictions, but now let's see this automatic hazard warning. Currently, it's a common one because there's no restriction for it. But let's see my product line is evolving. Now I have a feature here named hazard warning, automatic hazard warning. I want to use a feature to control the existence of this requirement. Yeah, I can just select this requirement in .ng by either using this restriction function on the toolbar to add a restriction, or I can directly expand the feature tree and drag this feature and directly job it on the requirements. In this way, you can simply add a restriction to your requirements. Very easy to use. Yeah. And besides this restriction, you see on the bottom, I also have another placeholder here. Inside in this placeholder, I have a feature, daytime running light and LED. And the pulse is actually the attribute I introduced you to earlier, meaning that I also want to take the value from my variant model, and then this value will be propagated directly to my requirements. Yeah. So meaning that by using pure variance, you can not only control the structural variability in your requirements, but you can also control the parametric variability inside in the requirements. Let's see, I want to open a variant model in this view. It's the baseline Sweden. You see some feature configurations, but please note you cannot make any changes here, because just a viewer, if you want to make any changes, you need to go to our web client or desktop client. Okay, now you see I have some configurations here, like this value for pulse is 100 and the feature automatic hazard warning is selected, of course. And then I want to show you another functionality is called preview. If I trigger the preview, you will see some magic here on the right-hand side. The requirements that won't be included into this variant, you can see they are grayed out. They are grayed out. And also you see the values here has been changed to 100. Yeah. But what I'm showing you is just a preview, right? You can double check the result, whether it's correct or not. If you want, you can simply reset the preview, because actually we didn't really make any changes, yeah, to my superset of the requirements, just a preview. I can simply reset this one. Okay, that's it. This is regarding the $G part. Let's go back. So after the $G, now I want to do something in my architecture models. So meaning that I will use the features, yeah, the similar features, the same features here, right? And then to control the variability, yeah, in my architecture models. Okay, then let's go ahead. So this time you see, I also have the pure variance into integration on the right-hand side. Yeah, it's quite similar, right? You see the feature models, 2 of them. You see the project name, and you see it's automatic hazard warning. You see the values of this pause and feature lat. And now this automatic hazard warning class is a common one. I want to do the similar thing. I want to use the feature to control the existence of this one. I would just use the into integration here, the functionality existence, and then just add a feature here. I can start typing auto, but by using the auto completion functionality of pure variance, I can directly select the feature I want, and then so then I want to open another variant model. It's the baseline Sweden, and then trigger a preview as well, like what we did for the G. You see here, these elements that are highlighted in green, meaning that they will be part of the variant. I mean, this baseline Sweden. But for this element that are highlighted in red, they will be removed, yeah, during the transformation. And transformation is another terminology in pure variance to tailor your superset and to generate the variant-specific SS, yeah, for this variant. Okay, then after this part, let's go ahead. Let's move to the test cases. Yeah, this time I will use the features, yeah, this colored features to control the variation points here, yeah, in my test cases in CodeBeamer. Let's go ahead. So you see here, yeah, on the right-hand side, yeah, I also have this pure variance widget. Yeah, for my CodeBeamer, you see the feature automatic hazard warning, the same feature models basically, and feature Sweden. And in the middle, this is the superset of my test cases. And I also have a common test case for automatic hazard warning now. And then I want to restrict this one by using this feature. I can also use drag and drop functionality, drag this one and directly drop it on this test case, and then the restriction has been added. So we can double check this one by using our restriction functionality. You see the automatic hazard warning, yeah, this feature is already there. Yeah. Okay, let's close this view. And then, yeah, besides the test case itself, I also have variability inside in my test steps. For example, here, there's a value for this seconds. Now it's 2 seconds. But what I want to do is I want to take the value, yeah, from my feature model or variant model, yeah, for this second. I can also simply drag and drop this attribute rhyme, yeah, from this view and then directly to the test steps. You see the calculation here, yeah, can be directly added to this test step. It's very easy to use. In this way, can also control the values by using our feature model, right? And then now I want to switch to the baseline Sweden, the variant model holding out configurations, and then trigger a preview. Okay. Now you see the similar thing, right? Some test cases that that are not belonging to this variant model will be just grayed out here. And then here you see the value, right? For this seconds, the reaction time has been changed to 2 because this is defined in my variant model. Yeah. But this is also a preview. Yeah. It just can see or can view the the future result, but actually we didn't make any changes directly in this super side. I can simply reset everything. If you want to really derive the variant specific test cases, we need to go for the transformations. Okay, then talking about the transformations several times, let's see how we can do that by using pure variance to tailor your super site requirements, architecture models, and test cases to generate variant specific assets for them. Let's switch to the pure variance client here. Again, this you see the feature models and variant models, but this time I will focus on this variable. I will switch to here, and then on the toolbar you see there is a button for triggering the transformation. So in my setup, I have transformations for different tools. Of course, you can trigger them one by one, but if you want, you can also wrap up your Dawson G, Magic Draw, and Co-Beamer transformation into one of them, and then you just trigger one transformation, and then you get the variant specific assets for all of them. Let's go ahead to trigger this transformation for Dawson G, Magic Draw, and Co-Beamer. Okay, so it's trying to connect to these tools and to tailor the assets over there. Now let's have a look at the generation. Firstly, in Dawson G, you can directly see this is subset, right? And you can see in this part, we don't have the requirements for the fog light because I don't have the feature selected, but I do have the daytime running light with this feature LED selected, and also the value is 100. And also the automatic hazard warning is here. Then if I switch Magic Draw, of course, this class for automatic hazard warning is here, and the value for pause is 100. Of course, you don't have the fog light, right? It's already removed. And then the next one is for the test cases in Co-Beamer. The similar thing, you have the automatic hazard warning test case, and also the value in your test tab has been changed to 2. This based on the configuration in the variant model. Okay, this is the running example, and let me go ahead. That's basically all I want to share with you today using my example with 3 connectors. But in the end, I want to recap that pure variance supports more than 20 connectors for widely used engineering tools, which enables the implementation of program engineering across your product, across your development life cycle. If you want to know more about our connectors, there is a playlist on our YouTube channel where you will find many videos about how to use pure variance with our connectors to manage variabilities in these different tools. Moreover, if you want to know or learn more about how pure variance can be integrated into your change management, your configuration management, continuous engineering, we also have videos out there with the corresponding tool. And of course, if you have any other questions, right, want to know more, you can also directly contact us. Okay, I think that's all for my part of my presentation, and I will give it back to you, Shivani, for the Q&A session.
Yes, thank you, Yang. That was pretty informative. And like Yang said, so no matter where you are in your product development lifecycle, pure variance would be there to your rescue. So now we have the question answer session. So feel free to use the chat system to post your questions. And we will have a look at them. Give me a second. Okay. All right. So, okay, we have one question here now. So what kinds of APIs does Pure Variance support in implementing any customized functions?
So actually, Pure Variance supports like Java and JavaScript APIs. If you want to know more information, please contact us. And also, if you want, you can also have a look at our user manual for the extensibility guide. So we have some information documented over there. Thank you.
Okay. All right. Thank you, Yang. Okay, we have some more questions. All right. So since we are running a bit out of time, I'm going to take these questions with me and we will contact you all individually. All right. And Ned says, Ned, we will take your question and we will contact you after the session. Yeah. All right. So then, thanks for joining today's presentation. And we have, I think, also in case you want to watch the recordings of our past webcasts, you can go to our Pure Variance YouTube channel. So there is a there is a playlist wherein you can find all the recorded webinars and and any kind of information that you would like to know about Pure Variance. So with this, thank you, Yang, for the great presentation. And all your questions would be answered. We will get back to you all individually. And yes, thank you so much for today's session.
Thank you.